So today we're going to be changing the IGBT. This is a Raptor drive on a York. They refer to this as the VSD. Each one of these screws is a capacitor. So every one of those, so this particular one's got 1, 2, 3, you got 8 capacitors total on this power assembly. This whole setup here is known as the power assembly for the drive. You've got your snubbers, your IGBT, which is also known as an inverter. Each one of these is an output leg to the motor. We're feeding DC volts into the IGBT, and then we're outputting a AC current to the compressor motors. To do this change, we've already verified it, but you're going to read across those terminals, and you want to verify through DC volts that you have 0. After you do a power down, it takes the bleed resistors 10 to 20 minutes to fully power that capacitor bank down. You need to give it that time before you start putting your hands in it. Verify that that bank is fully discharged. Otherwise, you will become the discharge. We're going to replace our snubbers. So when you go to do this job, always make sure you want to change these snubbers out. These are just little filter capacitors that go on there that help kind of clean the input voltage coming off of the DC bus. What you want to be careful with is that you don't over torque anything and crack any of the ceramic in the process. And this plug here is pretty simple, just a straight, comes right off, no big deal, and set everything aside. If you'll set your meter to capacitance, so it'd be this one up here. And then these are designed for a 1 microfarad at 10% variance. So you're going to read across there just like you'd read a regular capacitor. And we got 1 on the dot. That's what we want to look for. So these are still good, but they're really cheap and fairly disposable parts. So these are worth changing out. And you can see just you got physical cracking on the housing. This thing has been running hard and hot for many years. So it is definitely time to let this one retire. You're next going to pull these, and you're going to pull these brass or copper, these copper plates out. Get those out of your way. He's sitting there and he's pulling. There's 8 of these little Allens that go through and hit both sides of the IGBT board. So we got to pull these little Allens out, and once he does that, then we'll be able to fully pull the entire IGBT assembly out. Yes, from here you should be able to grab it. Now it may or may not be easy. Now keep in mind the back. So there are some, the plates. You have to slide it out from under that. Nice and gentle. There you go. Just like that. The next step's going to be, we'll take the IGBT board, the new one, and we're going to take the factory paste they send with it and just make sure we get a good even coat. Now we need to make sure that all that paste that's there is soft and malleable. It can't be hard. If any of it is hard or has hardened or gotten crusty, anything of that nature, it can get in the way of the new one creating a proper seat. And if that's where the paste is supposed to help give a thermal barrier to where it transfers heat better, but any obstruction will not allow it to transfer properly, and you'll struggle with it overheating and getting an inverter over temp alarm. Just right down the middle, you're going to just put a bead on all 3, and whatever extra you have left over, just kind of squiggle it around. Because what'll happen is we want it to build up and then compress out, so that way it evenly spreads. Can I meet you in the morning? One corner on opposite ends, that'll help it align. And then you want to evenly tighten this plate down so that everything smushes out properly. So your first goal is just for the alignment. These are the new snubbers that they are sending with them. These little black things. They've changed a couple of times over the years. So you could buy the old white ones. Now you've got these little black ones. So now that we've got the plate down and tightened down, we're just putting the snubbers back in, and we'll be able to tighten that piece of the circuit down. And then we'll come back up to the front here, and we will get the power cables hooked back up last. The critical part is this plug is what goes to your logic board and operates that IGBT assembly. what you really need to do is just, after you plug it back in, you're going to take a little thermostat screwdriver and you're just going to gently push it in and just depress that terminal down. One of the things that can happen is it will, between unplugging it and plugging it back in, the pins in these won't fully seat into the bottom pins, and it'll cause a little bit of a communication issue, and this board won't function properly, and you'll have just random little issues or IGBT faults, whatever. So if you go through and do that, that is a really handy just trick that will eliminate a lot of those problems. Now, a lot of people will tell you that anytime you change a IGBT, you want to change this cable with it. And while there is a lot of truth in that, in my personal experience, I've not had significant issues with it. And unless I'm already having an issue with the plug, I typically won't do that up front. But there are a lot of people, especially that work for the factory, that will actually recommend that. So you can make that personal choice as to whether or not you feel that's necessary according to your situation. From there, our next step would be to power it up. Make sure we don't have any faults, everything's communicating like it needs to, and then turn the circuit on. Now, the caveat here is I won't get to show you that today because we're still pulling a vacuum and what's got to finish and whatnot before we'll actually be able to get this turned back on and start it up. So, genuinely, I don't expect any issues. I've done this a number of times. Really smooth, really easy process. But, MTT guys, take care of your family, take care of your spouse. That's how you do an IGBT on a York Raptor VSD, also known as just a VFD, same thing.